Suppose you're a high school junior and you're at a Harry Styles concert or perhaps a Hozier concert. Your mom and perhaps your aunt or grandmom drove you to the concert. They're waiting in the parking lot in the car for you. And all of a sudden, because you're taking Algebra 2, this thought pops into your mind. And that is, why is it when you're doing transformations of functions, like the one shown here, if this is a vertical stretch, why is that a factor of 2? Look at this. It says 1/2 here. Where do they get factor of 2 from? That's what we're going to talk about in this video. So here is a formula that you may see in your textbook, and the one in your textbook might be slightly different. But the crux of the matter is this is g of x. That's now a transformed function. So what you need to analyze are the various coefficients and integers that you see associated with these locations. If you see something here out in front, outside of the parentheses, that's going to affect the y value. If you see something at the end, again, outside of the parentheses, that's going to affect the y values. The action having to do with the x values are inside the parentheses. Let's now look at these two examples quickly. This transformation, g of x, has the 3 outside of the parentheses. So that's going to affect the y values. Here in blue, that 3 is inside the parentheses, therefore it's going to affect the x values. And we're going to talk about those effects in a moment. Now, suppose your teacher gives you this. No parentheses listed. Whenever there's no parentheses, that means this function, this integer out here is outside of the parentheses. So these will be the same. Again, if you're given this, let's do this one in blue. No parentheses listed. That is the same as this 1/2 being outside of the parentheses. So you're going to have this phenomenon. That would be an effect on the y value. That is also an effect on the y value. Okay, next I'd like to talk about how I like to analyze transformations. We're going to be talking about the parent function y equals x squared. Recall that this is a so-called quadratic function and it's a parabola. And because there's a positive sign out front, it's going to be right side up. Okay, I like to call this parent function perfect parabola. And the reason is the width of the parabola is perfect. It's not too narrow, it's not too wide, it's perfect. So when you see a 1 in front of that x squared, it could either be 1 or -1. If it's -1, it's going to be upside down and a perfect width. This is a perfect parabola. Now, let's talk about these transformations. Both of these transformations are going to involve the x coordinate. So that means both of these transformations are going to involve the width of these wings of the parabola. Now, in order to review the difference between having a 5, which is greater than 1, or 1/2, which is less than 1, I'd like to pull up the picture of this cute dog. Excuse me. Okay, this is a picture of a dog. Let's assume this dog's physique is perfect. The dog is happy with his physique. The owners are happy. Everyone's happy. And that's because this dog runs 1 mile a day on a treadmill. Okay, so there's your 1 mile a day, perfect width of the parabola, perfect physique of the dog. Now, suppose all of a sudden this dog gets motivated and starts running 5 miles a day. That dog is going to get thinner. So this is going to be the parabola that represents 5 miles a day. Thin. Now, suppose the dog is so tired of running that he decides, I'm not only going to drop down from 5 miles a day, I'm not even going to run 1 mile a day. I'm going to run one half of a mile a day. What's going to happen to this dog's physique? If he eats the same amount of treats, the dog is going to get heavier and he's going to get wider. Okay, should have done that in yellow. So this one half, with the dog only running one half a mile a day, he's going to have a wider physique. If he runs 5 miles a day, he's going to be too thin. If he runs 1 mile a day, he's going to be perfect. Okay, suppose you have this on your homework and they ask you, what is this yellow transformation? Describe it. Well, the first thing you notice is that 1/3 is inside the parentheses. So you know this is going to be a transformation in the horizontal direction. There's the 1/3. That is less than 1. The dog is running less each day, only 1/3 of a mile. So now this new parabola is going to be wider. Like so. So what is this, ladies and gentlemen? This is a horizontal stretch because these x values have gotten bigger. Okay, now I'd like to talk about why that is considered a horizontal stretch with a factor of 3. So let's look at this. It's very confusing. If they ask you for what the factor is, this is a factor of the reciprocal of 1/3, factor of 3. Now, why is that? Here it is. Let's look at this original green parabola, okay? If we look at this location right here, this y value right here, and we draw a line straight across, okay? So that's the same y value for both situations. Okay, here's the before, and here's the after the transformation. Okay, we know it's wider because the dog is only running 1/3 of a mile. If we look at this same y value and we look at the before x value, it's going to be here. Let's call that 2. Now, if we look at that same y value and we look at the after, that x value is now 6. Look at this. 2, 4, 6. It was 2, now it's 6. So this wider transformation resulted in the x values increasing by how much? 3. 3 times 2 gives you 6.